Thank you, everyone. My name is Neway Kifle. I'm a remote sensing and geoinformatics student in Addis Ababa University, Ethiopia. And my research title is Mapping the Effects of Urban Blue-Green Landscapes on Land Surface Temperature using Geo-Spatial Techniques. It's a case study of Addis Ababa. So this is my presentation outline, which I'm not going to read it. So I will start my introduction by defining urban blue-green landscapes. So according to the UN Habitat, urban blue-green landscape refers to all the green and blue areas in the city, including parks, private gardens, rivers, ponds, and river banks. And several studies have shown that this urban green landscape could absorb carbon dioxide, release oxygen, lower the air temperature, increase air moisture, reduce dust concentration and noise level in cities. So like the green landscapes, urban blue-green landscapes also provide ecological services like carbon sequestration, oxygen production, noise reduction, microclimate regulation, and recreation and social services in cities. And remote sensing, particularly thermal remote sensing, is very significant in monitoring land surface temperature and assessing the thermal properties of Earth's surface materials, as well as their relationships. So as a statement of the problem, so the governments, the different successive governments in Ethiopia have different priorities and projects regarding the development of the Addis Ababa city. For instance, Imperial Minilik was interested in building the National Palace, introducing the first gravel road and the marketplace in the city. And then is Imperial Haile Selassie, who was known for building the monuments, the Lion of Judah statue, and the Holy Trinity Cathedral Church in the city. And then comes the Derg, who restored the Mescal Square for its military parades and took the imperial properties. After that is the Ethiopian People's Revolutionary Democratic Front, the EPRDF, who was known for introducing the first light rail transit and expansive condominium social housing scheme in different parts of Addis Ababa. And more recently, the current administration introduced a new green intervention called the Green Legacy Campaign, and also the Beautifying Shagger or Addis Ababa mega project in the city. So during the first Green Legacy Campaign, which was held during the rainy season of Ethiopia, so 4 billion seedlings were planted across the country. And at the second campaign, which was held in 2020, 5 billion seedlings were planted, that is across the country. And when it comes to into Addis, during the second campaign, 7.8 million seedlings were planted in the city. And on the other hand, the master plan of the city has also developed strategies that focus on the blue-green developments in the city. And the mega projects like the Beautifying Shagger project clearly illustrates the government's focus on the blue-green intervention in the city. And this mega project is expected to raise the green coverage of the city from 0.3 to 7 square meter per capita. So this is part of the recent blue-green intervention, which is found in front of the National Palace in Addis. So this shows us a political shift in ideology and priority in the urban development of the city. And this study is mainly intended to map the urban blue-green landscapes effect on land surface temperature using geospatial techniques. So objectives. The main objective of this study is to map the effects of urban blue-green landscapes on land surface temperature using geospatial techniques. So in line with the main objective, this study has 4 specific objectives. The first one is to estimate land surface temperature. for the 3 different years in the city. The second one is to map the land use land cover using object-based image analysis and high-resolution imagery. The third one is analyzing the spatial-temporal pattern of land surface temperature and its variation among the different land use land cover classes. And finally, to study the impact of the urban blue-green landscapes on land surface temperature using the vegetation built-up and water indices. So this is my study area map. So regarding the materials, methods, and softwares, so this is the flow chart for this study. As you can see here, this study is conducted in 5 stages. The first one is data collection, in which data was obtained from different sources. For instance, I used Spot 5, which is commercial one, and also Sentinel-2, which is freely available with a resolution of 10 meters, and then also Landsat 7 18 plus and Landsat 8 with a resolution of 30 meter. I also used MODIS land surface temperature product with 1 kilometer just for the validation purpose. And for the classification accuracy assessment, I also used field data and Google Earth data. So the second stage is image pre-processing, where different kinds of image pre-processing activities were carried out, like atmospheric correction, skyline error correction, and so on. The third one is image enhancement, where I calculated different land use land cover indices like NDVI, NDBI, and modified normalized difference water index to enhance vegetation, built-up, and water indices respectively. And then is image classification, which is the fourth stage. Actually, image classification and the land surface temperature retrieval, where object-based image analysis is applied to classify the land use land cover, together with its accuracy assessment. And also land surface temperature retrieval is also carried out using the bands from Landsat 7, band 6, and from the Landsat 11, from the band 10 from the Landsat 8 tiers band, together with its validation. And the final stage is statistical analysis, where I used linear regression to determine the relationship of land surface temperature against the 3 land use land cover indices. And these are the list of the softwares that I used. So these are the equations that were applied to calculate the land surface temperature. So to standardize the land use land cover classification, I used the USGS classification system. So I do have the built-up, the vegetation, urban farmland, pearland, and water land use land cover classes. So these are my results. So for the accuracy assessment, you can see, So this is the result for the overall accuracy assessment and the overall kappa statistics. So it shows above 90, indicating that the classification is it highly agrees with truth in the ground. So for the land use land cover change, the statistics. So as you can see, the built-up land use land cover class showed an increasing trend for the last 15 years at the expense of vegetation, urban farmland, and pearland. And the water land use land cover class remained relatively unchanged. So when you look at the last column of the table, you can see the annual rate of change for the built-up class. It's a 4.38, which is 9.27 square kilometer. And the others, and these figures shows that the vegetation, urban farmland, and pearland are diminishing through time in the city area. So this is the map for the land use land cover change for 3 different years. A is for 2006, B is for 2016, and C for 2021. So the one at the middle, the one which is represented by the cyan color, represents the built-up. So you can easily understand how the built-up land cover class expanded through time at the expense of the bare land, which is highlighted in red, and the urban farmland, which is in yellow. And you can also see the vegetation cover at the at the north, where there is a in total mountain. It's densely vegetated, and also along the river banks in the city. So this is the land use land cover conversion matrix, which shows you which type of land use land cover is changing into what. So I highlighted it with red. You can see here how the bare land changed into the built up by 59% during the last 15 years. The urban farmland changed by 53.73 into built up, and also even the vegetation itself changed into the built up by 48%. So this is the result for the land surface temperature validation. So 86%, 81%, and 80% of the pixel values extracted from the Moody's land surface temperature and the estimated raster showed a maximum difference of plus or 2 degrees Celsius. And you can also see the result for the spatial temporal pattern of land surface temperature. As you can see, the mean land surface temperature showed an increasing trend during the last 15 years. And considering the whole range of time from 2006 to 2021, the land surface temperature in the city increased by 2.4 degrees Celsius. And this is the map for the 3 different years. So as you can see, the one highlighted in blue is lower land surface temperature values, and the red with the highest one. So the lower land surface temperature, the lower mean land surface temperature values are observed where there is vegetation in the northern part of the city, and the higher values are mostly, observed in the central and southern part of the city. So this is the result for the land surface temperature for the 5 land use land cover classes. So as you can see, the one highlighted in green shows you the lowest mean land surface temperature values. So the lowest values for the mean land surface temperature were observed among water and vegetation land use land cover classes. So on the other hand, the higher values were observed among the urban farmland and bare land use land cover classes in the city. So this is a regression result for land surface temperature with any DVI, any DBI, and the water index, M and DWI. As you can see here, the Pearson moment correlation coefficient, which is R, it tells you that the NDVI is negatively correlated with land surface temperature, and the NDBI, the built-up index, is positively correlated with land surface temperature, and the water index is negatively correlated with land surface temperature. And also the R square values tells you it is higher for NDVI and NDBI, but it is lower for the water index in all the 3 years, indicating that most of the variations in the land surface temperature are explained by NDVI and NDBI compared to the water index in the city. And this is the scatter plots of NDVI and land surface temperature for the 3 different years. So for your visual interpretation. And here comes the scatter plot for land surface temperature and NDVI for the 3 different years. And this one is land surface temperature against modified normalized different water index. So as a conclusion, the findings of this study reveal that there has been a substantial transformation between land use land cover classes, and the expansion of built-up areas is the most prominent phenomenon and is responsible for the shrinking of urban farmland, bare land, and vegetation coverage in the city since 2006. And the findings indicated that land surface temperature varied both spatially and temporally throughout the study periods. And the land use land cover alteration had contributed to the modification of land surface temperature in Addis during the study period. And like I said, NDVI and NDVI are the 2 most important parameters to predict land surface temperature in the study area compared to the water index. And lastly, this study witnessed the potential of integrating remote sensing and GIS for investigating the urban thermal environment with respect to different land use, land cover classes. So these are my recommendations. The first one is, the urban planners and policymakers has to consider diversified green landscapes like green buildings with green walls and roofs, street greening, small and large parks, and green trails and playing grounds in the city. And it's also recommended that planning and designing should be based on changing and future demands, and the blue-green development opportunities should be promoted and extended into other sectors and projects like schools, real estate, shopping centers, and so on. And it's also recommended that it would be beneficial to consider the construction of man-made lakes within the green areas because it helps to strengthen the cooling effect, and as it was a case in the Friendship Square in Addis. And the authors realized that some other driving forces of land surface temperature other than land use land cover dynamics like altitude and some other factors are not considered in this study. And also we believe that the temporal extent should also be widened to better understand the land surface temperature trend and the associated land use land cover change in the city. This is the end of my presentation, and thank you very much for your time.